Hmm. Let's see if the stream has started. Pretty late today. It's already 6:30. I thought that I'd do one stream in the noon because I had a lot of time in the noon. My classes were over after 2, so I had a lot of time. I could have streamed for 1-2 hours at least in the noon, but I didn't actually because of some medical issues. But anyways, I thought let's not waste this time and let's try and stream in the time that I have. So, welcome to the stream. Uh, Yesterday was the first day. Today is second day. So from now on, I'm going to try and incorporate some things that will help me improve my entire streaming habits. Plus, at the same time, I want to improve my DSA also. So target for today's stream is basically to be able to solve most of these questions. I have around 9 questions, 8 to 9 questions that I want to solve during this stream. And what I'm going to do is basically I'm going to try and solve 3 questions at a time, and as soon as I've solved like 3 questions or 4 questions, I will once again explain how I've solved those questions. Um, so yes, when I'm solving questions, I will turn off my mic and also video so I can just focus on the question itself. And once I've solved 3 questions, I will bring everything back and we'll start discussing them. Also, I have this timer thing set up here that can help me keep track of the time also. So that's pretty much it. Let me start the stream and let's go ahead and solve these questions. Um, I thought of playing some music in the background, but that I'll do next time, not right now, because I've already set up everything. So let's just start. Okay, let's start with three. Let's choose 3 questions that we want to solve right now. 3 questions that I want to solve right now. Okay, definitely want to solve. So there are questions that are related to best time to buy and sell stocks. How about we solve those questions first? Okay, let's try and solve these 3 questions first. Okay, so this is the target. Let's try and solve 3 of these questions, and then I'm going to discuss how I solve them. So this is something that I've already solved, I guess. Let me remove it. This is also, I've solved those questions at some point of time in my life, but anyways, these are the 3 questions. So let's go. Let's go ahead and start the timer. Before starting the timer, let me take the video out of the screen. Let me also remove the audio, or maybe just, yeah, I'll have to remove the audio. That's the only way. Okay, so let's remove the audio. And after removing the audio, I will start the timer and we'll start solving the question. See you on the other side. Hello, 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 hello. I think I'm audible now. Yes. So, okay, I've done three questions. Not the ones that I ticked, but yes, I did three questions. Let me open them up in separate tabs. There you go. Last one is this. So, I earlier decided that I would be. Let me check if I'm even audible or I'm just talking without my voice being audible. Yeah, I'm audible. Cool. So, let's also turn this off. Let's reset this. I think it took us around to solve this one also. Best time to buy and sell stocks with cooldown, but I don't think I can do it right now. I think it need wanna be able to do these four questions after solving rest of the remaining ones. So this is the first one that I solved. Best time to buy and sell stocks. Very straightforward. I've given I've given an array prices where each index represent the price of the stock on that particular day. Now what I can do is I can choose any day to buy the stock and then sell the stock in the future on any day, and I can book the profit. Now I have to figure out what's the maximum profit that I can book. So the simple algorithm that I wrote for this is basically at every step I try to see um, if I sell the stock on this particular day, what would be the profit? And I return the maximum of the profit. So basically, for every index, if I choose index I, and if I choose to sell the stock on that particular index, um, from 0 to I minus 1, the minimum number would be the day which on which I should buy the stock in order to get the maximum profit. So to take care of that, I've used this variable till now, and the answer is the variable which will contain the final answer, which is the maximum value of the overall price of the profit, overall profit that we have booked over the n number of days. Very straightforward question. Next up, this is a slightly advanced variation of the previous question where this time I can buy and share at like at many times as I want. And this time, what I've done is basically I've followed the similar method where at every index I'm trying to sell the stock, and if I can sell the stock, then I will add the profit to my final answer. So this can be visualized in a very simple way. If you think of it as a graph, say 7 is here, 1 is here, 5, 3, 6, 4. So it's a graph with peaks and valleys. The idea here is that every time I encounter a price which is higher than the price of the previous index, I should buy and sell in that particular interval to book the profit, and I can do that as many times as I want throughout the array, and overall uh, the answer would be the most optimal answer that I can have. So another question, very easy. This was the easiest, sum of beauty in the array. It was hard to understand the question at first, but as soon as I understood the question, it was slightly easier. Also, this is similar to the problem. This is similar to the category of problem, which are like rainwater trapping problem or largest rectangle in a histogram problem. Similarly, this is sum of beauty in the array. All of them are pretty similar. The concept is very same. You have to find the largest number until this index and smallest number until this index, and then you can get your answer by some calculations. So those are like similar questions, so I was able to solve it also. Now the idea is to be able to solve these questions, but I don't think they are um, I don't think they have a practice link where I can go and try out these questions and try to understand how they are solved. So for example, this is the first one, optimal strategy. This is styling with dynamos. There is longest arithmetic progression, and there is maximum sum rectangle. I think longest arithmetic progression is a question that I do not really want to solve because I don't find it that interesting right now. So for this one, um, longest arithmetic progression, I'm gonna color it red because I don't find it interesting enough to be solved right now. Okay. Why have I not solved these problems? Maybe, yeah, maybe I haven't solved those problems. But anyways, um, so I have these three problems. The bad part is that they don't have a practice link where I can go and try out them myself without reading. Also, I do not know if I really want to do that or not. But either way, let's try and find a link on LeetCode if it's possible. So maximum sum rectangle in 2D matrix. You have to find the maximum sum rectangle in a 2D matrix. Let's go to LeetCode and let's try and see if there is a problem with the same given rows. You have to find the largest rectangle containing only ones and return its area. I think this is slightly easier because in this case it's similar to finding the largest square in a matrix, but definitely I would like to solve this one either way. So let's first try and solve this. Okay, I'm gonna solve this one while speaking. So how to solve this one? Okay, I'm gonna create a DP array of length. Okay, let's have rows and columns. So rows is length of matrix and columns is length of matrix of 0. This is range columns, this is for j in range rows. Yep. Now I have to find the largest rectangle containing only ones and return its area. So what I'm gonna do is first I'm gonna go and say for I in range rows. Let's go to every row, and in every row what I'm gonna do is I'm gonna say dp of I of 0 is basically whatever the matrix of I of 0 is. Similarly, I'm gonna go in every column and I'm gonna do dp of 0 of I is nothing but matrix of 0 of I. Now these have ones and rows. Now I'm gonna write the main loop where I have rows, I have columns, and here I'm going to do something, right? Um, yeah, I'm gonna have some answer as 0. I'm gonna return answer. Answer could be basically this um, rows for j in range columns. Answer equals to max of answer comma dp of ij. Okay, so this could be a solution. I just have to write some things here. All right, so I have to find the largest rectangle containing only ones. In this case, the largest rectangle containing only ones is this small one. So the area is 1. I have to return the area, right? Okay, find the largest rectangle containing only one and return its area. Okay, now it's interesting. I have to return its area. Hmm. Okay. Largest rectangle containing only once, return its area. Oh, I don't think this could be solved using this method. I think instead what we have to do here is slightly different. So from this example array, what I have to create is I have to create for maybe hmm, okay, I understand now. So the length is 200. Okay, cool. So for from starting from first row till the last row, what I have to do is I have to create histogram and I have to find maximum area rectangle inside of a histogram. Um, okay, and in order to do that, I can okay, maybe let's go to Jamboard and let's try and do something on that. How do I go to Jamboard? Google Jam. Yes, कौन है? हाँ अच्छा हाँ दिया Just a second. Okay, sorry for the noise and delay. Um, there was someone on the door. I live in a hostel, by the way, so of course. Anyways, so what I'm going to do is I'm gonna open Jamboard somehow. I don't know how to figure out. Okay, got it. How do I open Jamboard? I have used it earlier. See, I've used it earlier, but I didn't know कि इसको use कैसे करूँ अभी. But never mind. So here is our Jamboard. So this is the plan. This is what I feel could be done in this particular problem. Yeah. So we have this array. Okay. Maybe I can take a. What did I click? Should have been clicking on snipping tool. Okay. Let's take this array. Let's place it on the green Jamboard. Now let's go ahead and start writing stuff. Okay. So what I can do is when I'm at the first column, 1 0 1 0 0, and I have to find the maximum area of the rectangle inside of it. Similarly, when I'm at the second one, it's gonna look 2 0 2 0 0. Similarly, when I'm at the third one, it's gonna look 3 1 3 2 2. All right. Um, so usually, let's also do the same thing for 4. So it's gonna be 4 0 0 3 0. Now, if I go ahead and try to convert it into bar graphs, for example, especially this one, let's do it here. So this is 3, this is 1, this is 3. Let's say this is the bottom line, this is 2, and this is 2. Now I have to find the max area rectangle inside of this um, histogram. So this is a histogram, and I have to find the max area rectangle in this histogram. So in our case, it's going to be this one, and this is going to be our answer, right? Um, so essentially, the entire problem can be broken down into max area histogram. And to find out the max area histogram, what you can do is you start from I equals to 0, go till I equals to n. For every index, what you do is you see what is the maximum area of rectangle that you can create, including this particular ith index wala bar. So for example, if you include this in a rectangle, then the max area of a rectangle would be this. Okay, how to find out that? Well, you go to the left side and you check uh, the largest, or maybe so you have to find the rectangle, right? So what you do is you go to the left side until you find the smallest. uh, so you go this side until the that thing is small, right? Until the index gets smaller. So you have to find the index of uh, so for example, you can have two arrays in this case. One array would be having so for example, when I do array 1, this is array 1 of current I, then what I want to have is I want to have index, right? Index of an element smaller than I, smaller than current, right? Current element. In this way, I can say that until that index, I can create a rectangle. Similarly, if I do array 2 of j, array 2 of I, then I want to have index of an element which is smaller than current element. But this array 1 will have for the left side, and this array 2 will have for the right side. And by using both of these arrays, I can get the area of rectangle or at particular index, and I can run the loop for 0 to I and find the maximum area, and that would be the maximum area of rectangle inside of this histogram. And similarly, I can check for all the possible histograms by looping over the rows and I can calculate my answer as answer equals to maximum of answer comma max area of the rectangle inside of that particular histogram on the index I, and I can get the answer, and that would be the final answer. Let's see if I have submitted this. No, I haven't. Do I want to submit it? No, because it's very repetitive. I know how to solve it, and I've solved these kind of problems earlier, so let's not go there. Let's come back to this particular problem, um, where the problem says that you are given an array, and you have to find the maximum sum rectangle inside the 2D matrix. So the idea I remember vaguely. The idea here is very similar to the one that we use for one-dimensional array. So if you have like one-dimensional array, what you can do is basically you can try and find the um, max area, max sum subarray from that array. So if you have one-dimensional array 1, 2, minus 1, minus 4, and 1 minus 20, then maximum subarray would be this, and the maximum sum would be 3. Here you have to find the maximum sum rectangle, and you have to find the you have to return the, what do you have to do? Do you have to return the answer, or do you have to return the ij? I guess you have to return everything, so that's more interesting. Okay, how do we solve this problem? There is the similar approach that we use to solve this problem also. Um, how you do that actually is that you have, I don't actually remember how to solve it, but the idea is to fix the left and right column by 1 and find the maximum sum contiguous rows for every left and right column pair. We basically find top and bottom row number for every fixed left right column pair. To find the top and bottom row number, calculate the sum of element in every row from left to right and store the sum in this. So indicate the sum from the, if we apply Cardan's algorithm on temp and get the maximum sum subarray of temp, this maximum sum would be the maximum sum possible, maximum possible sum with left and right as secondary boundary columns. To get overall maximum sum, we compare the sum with the maximum sum so far. Okay, makes a lot of sense. So you have to fix columns first. Hmm. Okay, makes sense. So I think the algorithm here is basically you, let's say you are on the first column, and you choose the second column also initially. So now for these two columns, let's try and find out the maximum sum rectangle. How you do that is basically you store the sum of elements inside a subarray in a different array, let's say temp array. So here, right here, as you can see, we have temp, which is 0 times of row, which means initialize all elements of temp as 0. Row is the number of rows. So in every row, the elements would be, so if I take sum, it is going to be 3. If I take sum, it's going to be minus 15. Again, if I take sum, it's going to be 11, and it's going to be minus 5. So if I had to find the answer from just these two um, rows, then that would be possible pretty easily if I are using this array. And now inside of this array, what I can do is I can basically choose to have the maximum sum subarray from this array. And the maximum sum subarray would be just this, right? The maximum sum subarray is just this. So the answer would be to take this rectangle. This rectangle would be the would give you the maximum sum if you're just talking about these two columns. But you can do more by simply so similarly, if you are here and here, then you figure out that the sum here is nothing but minus 3, this is 3, this is 19, and this is 7. So this is the maximum sum subarray. So you take these three, and this is your answer. It's a very straightforward and pretty simple um, problem. So I thought it's very tough, but apparently this what do we call it, maximum sum rectangle problem is very simple, to be honest. Um, let's do this color for this particular problem. Maximum sum rectangle. I think we have already done this, so let's delete this row. It's a very easy problem. Next up we have um, Tiling with dominoes. Have I not solved this? Largest area with equal number of zeros. I can try that also later on. But let's first try tiling with dominoes. So given a 3 into you're given a 3 cross n boards. Find the number of ways to fill it with 2 cross 1 dominoes. Okay. So for example, if you're given 3 cross n board. Okay. So this is the board, let's say 3 cross n. 3 rows and columns. So let's have 3 rows, 4 columns. So this is 3 cross 4. I have to cover this up using 2 cross 1 slide dot tiles. I can do that. How will I do that? So a possible solution would be to use this tile here, tile here, tile here, tile here, and then tile here, tile here. What do you have to find? You have to find the number of ways to fill this particular domino. So if I'm going to use dynamic programming here, well, how will I solve it using dynamic programming? Hmm. Okay, so I have to solve this using DP. Okay, alright. So what if I have filled these, 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 and these entirely with the things. And now I say that I'm going to increase this to 3, 5. See, this is totally possible. I can increase it with 1. And now I want to see what are the possible ways of figuring it out. Well, from this solution, I cannot fill this up. There's no way, right? But, hmm, but maybe I can fill this up if I had like, so if I go to eraser, let's erase all of this. This is not useful anymore. Okay. Maybe I could have had 3 comma 6, and in that case it is possible to fill. So the number of ways still here and the number of ways to do this. So I think a solution could be to figure out, so if it's just a 3 cross 1, then we cannot have any, so the answer is 0. But if it's 3 cross 2, in that case 3 cross 2, in that case there are a lot of answers. I can figure out the answer, and I can use I can use this information to solve the rest of one. So in case of 0, base case 0, what's A and B? um, A is the number of ways to completely fill a 3 cross n board. B is the number of ways to fill a 3 cross n board with top corner in the last column not filled, and C is the number of ways to fill with the bottom corner in the last column not filled. Mm, even though B and C are different, they will be equal to n, right? Mhm. It's A of, oh, that's very weird. That's really weird. That's really weird. I am not going to look at this problem right now. I'm gonna do that off stream. Some problems we will leave for off streaming because if I'm going to solve all the problems on stream, that's just not possible. Okay, let's see कितनी बड़ी stream हो गया. The stream is 44 minutes now. I have to stream for more time, but just give me a break. Like I'm getting a call, so I'm gonna mute myself.